Chapter 7, Right Triangle Trigonometry. Lesson 7.3. Use similar right triangles. If the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So, our altitude to the hypotenuse means it goes from the right angle down to the hypotenuse. So if we draw that altitude, so it makes a right angle with the hypotenuse, the three triangles are all similar. So this little one on the right, which is blue, is similar to the big triangle. The little one on the left, the medium-sized one on the left, is similar to the original triangle. And the two smaller triangles are similar to each other. Why is that? It's from the AA similarity, because they all have a right angle. And angle A is congruent to angle A, so the red one there is congruent to the big one, or similar to the big one, sorry. And angle B here is congruent to angle B. So the blue triangle has two angles in common with the big triangle. And because of that, we know, since they're both similar to the same triangle, we know they're similar to each other. We know those angles are like that. So, looking at this picture, identify the similar triangles and then find the value of x. So to do this, I'm going to kind of divide it up. So there's the outside triangle. There's the medium triangle, and I'm going to rotate it around. And there's the small triangle, which I'm also going to rotate around. So from that, I know all the sides of the big triangle. And so I can, since they're all similar, we need to identify the similar triangles. So I can say triangle EFG is similar to, well, EF is the hypotenuse of the outside large triangle. So the hypotenuse of the medium triangle is GF. And the right angle is G. So the right angle of the medium triangle is H. The hypotenuse of the little one is EG. And the right angle is H. So I had the hypotenuse and then the right angle. Hypotenuse, right angle. Hypotenuse, right angle. So then I can make my proportion. So let's say I use the medium triangle. I know the short leg and the hypotenuse. So I'm going to go short leg over hypotenuse. So the short leg is x, hypotenuse is 4. On the outside triangle, this is the short leg and this is the hypotenuse. So that would be 3 over 5. Could cross multiply 5x equals 12 and divide by 5, so x would be 12 over 5, which is the same thing as 2.4. We could have also used the small triangle and the biggest one and gotten the same answer. And we have another theorem. If an altitude is drawn to the hypotenuse of a right triangle, then the altitude is the geometric mean of the two segments of the hypotenuse. So because they are similar, BD to CD, that's the short leg to the long leg. So in the medium triangle, the short leg is CD. The long leg is AD. So then we could cross multiply, and you would have CD squared equals BD times AD, and then you could square root. The square root of the two things multiplied together is the geometric mean, and that's the two parts of the hypotenuse. So the altitude, CD, is the geometric mean of the two parts of the hypotenuse. And another theorem, the altitude is drawn to the hypotenuse of a right triangle, then each leg is the geometric mean of the hypotenuse and the segment of the hypotenuse adjacent to that leg. So let's take, say, that's the hypotenuse and that's the short leg of the outside triangle. Hypotenuse and the short leg. Of the little tiny triangle, the hypotenuse is CB and the short leg is DB. So if I cross multiply, I'll have CB squared equals AB times DB square root. So CB is the square root of AB times DB. So that's the hypotenuse times part of the hypotenuse. So the leg, CB, is the geometric mean of the whole hypotenuse and the part of the hypotenuse touching that leg. Or you could just use similar triangles and get the same thing. So let's find x or y. In this case, we'll find x. All right, in this case, x is a leg. So according to our theorem, our leg is the geometric mean of the hypotenuse and part of the hypotenuse. So our leg is x, and the hypotenuse would be the whole thing, which is 9, and the part of the hypotenuse touching the leg is 5. That'd be 45, square root of 45. Square root of 9 is 3, so it's 3 square root of 5, which is approximately 6.7. In radical form and decimal form. You could have also set it up with similar triangles. We could have taken this triangle and the main outside triangle, and we could have done leg over hypotenuse, let's say. The leg is 5, the hypotenuse is x. On the big outside triangle, the leg is x and the hypotenuse is 9. Cross multiply, x squared is 9 times 5, square root 3 square root of 5. Let's try another one. This time, we're looking for the altitude. The first of those two theorems said the altitude is the geometric mean of the two parts of the hypotenuse. So the two parts of the hypotenuse are 5 and 8. 5 times 8 is 40. Oh, let's see. 40 is, if I have a perfect square, it'd be 4 times 10, which is 2 square root of 10. Which is approximately 6.3. Be careful to read whether they want radical form or decimal form. The other way you could have done it is you could have used the two smaller triangles, done something like short leg over the long leg. On the left triangle, the short leg was 5, the long one was y. On the right triangle, the short leg was y, the long one was 8. Cross multiply, square root, get 2 square root of 10. So you can either use the theorems or you can use similar triangles and get the same results. That's all for today. Have a great day.